Assalamu alaikum. So this is the main result of lecture 5 about the product of finitely many compact spaces is compact. तो इसके लिए enough to prove for two spaces, so you can prove the results by using the inductions, because if I will prove that for x and y is compact, implies their Cartesian product is compact. So for finitely many spaces mean x1 cross x2 cross so on cross xn. ठीक है. सो अगर आप ये प्रूव कर दें कि दो स्पेस ये टू स्पेसिस की कार्टियन प्रोडक्ट कॉम्पैक्ट है, तो तीन के लिए आप कैसे प्रूव करेंगे? x1 क्रॉस x2. सो फॉर टू इट्स कॉम्पैक्ट अगेन. सो दिस इज वन स्पेस z and cross x3. So this will become z cross x3 again for two spaces. ठीक है. इसी तरह थ्री स्पेसिस के लिए प्रूव हो जाएगा, and then for by using the inductions. ठीक है. So by using the inductions you can prove that enough to prove for n is equal to 2. ठीक है. So then for the Cartesian product for 1 to n xn is compact for each xi if your xi is compact. ठीक है. So I will prove just for two spaces. ठीक है. So प्रूफ के लिए मैं लेट कर लेती हूँ. एक बात ध्यान में रखें, ट्यूब लेमा इज द की. सो ट्यूब लेमा इज द की. ठीक है. सो ट्यूब लेमा क्या है? ट्यूब लेमा ये है कि अगर सो आई विल राइट द स्टेटमेंट ऑफ ट्यूब लेमा अगेन. So what is tube lemma? Tube lemma is saying that if x and y are the product space, ठीक है, and if x naught cross y, okay, tube lemma में ये जो space है ये compact space है. ठीक है, and y is a compact space, and if x naught cross y is a slice, and n is an open set such that open set of the product space, ठीक है, such that x naught cross y is contained in n, then there exists an open a neighborhood of x naught. ये जो आपका w है ये क्या है? आपका neighborhood of x naught in x such that your x naught, the slice is contained in tube, okay, and the tube is contained in the neighborhood, and neighborhood is the subset of xn. ठीक है. सो ये आपका ट्यूब लेमा है. सो नेक्स्ट मैं प्रूफ पे आती हूँ मेन थ्योरम के. सो प्रूफ इनफ फॉर टू स्पेसेस. ठीक है. फॉर n is equal to 2 I will prove it. सो लेट कर लेते हैं कि x क्रॉस y be the product space of x and y, and your x and y are compact. ये ध्यान में रखें, x and y are compact. ठीक है. सो इसके लिए चूंकि की जो है वो आपका ट्यूब लेमा है, सो ट्यूब लेमा के लिए क्या करना पड़ेगा? मुझे पहले स्लाइस लेना पड़ेगा. सो आप ये देखेंगे गिवन एनी ऐसे x नॉट बिलोंग्स टू x. ठीक है. वी हैव x नॉट क्रॉस y is the slice of slice in in the product space. ठीक है. slice in the product space. अच्छा, अब आपने ये प्रूफ करना है. आपका क्लेम क्या है? क्लेम आपका ये है कि जो आपकी प्रोडक्ट स्पेस x क्रॉस y इज कॉम्पैक्ट. तो कॉम्पैक्टनेस के लिए क्या कहते हैं? यू टेक एन ओपन कवर एंड यू हैव टू फाइंड द फाइनाइट सब कवर. सो लेट कर लेते हैं कि a alpha for alpha belongs to the index set be an open cover of the product space x cross y. ठीक है. So this implies your product space X cross Y is contained in union for alpha belongs to I and alpha belongs to I and this is your alpha. ठीक है. अच्छा, अब ये ध्यान में रखें कि अगर मैं कोई भी पॉइंट लेती हूँ, ये स्लाइस जो होगा, ये जो स्लाइस होगा, स्लाइस विल बी द सबसेट ऑफ द प्रोडक्ट स्पेस. सो फॉर any x belongs to x naught, say x naught belongs to x, we have x naught cross y is contained in x cross y and this is contained in this open cover. ठीक है. सो यहां से ये पता चलता है कि स्लाइस का ओपन कवर जो है वो ये भी होगा. सो दिस implies x naught cross y is contained in union for alpha a alpha. So what does that mean? This implies your a alpha is open cover of the slice x naught cross y. और ये जो slice है, this x naught cross y is a compact space because your x naught cross y is homeomorphic to y and y is compact. ठीक है. So this implies your slice is compact. So there exists the finite subcover using the compactness a1 a2 and an. Okay, ये बात आपने ध्यान में रखनी है कि ये जो सब कलेक्शन है, ये जो फाइनाइट सब कलेक्शन है, इट डिपेंड्स ऑन दिस पॉइंट. आपने पॉइंट चूज किया है, यू चूज अ स्लाइस एंड यू गेट दिस सब कलेक्शन. ओके, सो दिस सब कलेक्शंस डिपेंड्स ऑन दिस पॉइंट x naught. Okay, so there exists the finite sub collection contained in A such that your x naught cross y is the subset of union for I from 1 to n ai. Okay, and this collection, मैं रिपीट कर रही हूँ, this collection depends on x. बल्कि मैं एक काम करती हूँ, मैं इसके ऊपर छोटा सा ना x नोट भी लगा देती हूँ, बल्कि 1 मिनट. सो लेट कर लेते हैं, अभी मैं बताती हूँ x के साथ कैसे. ओके, सो लेट कर लेते हैं कि दिस union of the open set is open. So we denote this with the n say x naught because this collection depends on x naught. So this is open set in the product space. Okay, so this implies your x naught cross y is contained in n x naught. और जहन में रखें n x naught क्या है, मैं यहाँ पे दोबारा लिख रही हूँ. n x naught is actually n x naught क्या है, n x naught is the n x naught is the finite union of elements in A and depends on the selected point x naught. Okay, so so this is a slice and slice is contained in the open set. Now here you can use the tube lemma. Use the tube lemma. There exists a w x naught and this is the subset of x and this is the neighborhood neighborhood of x naught such that your x naught cross y is contained in wx naught cross y and this is contained in nx naught. Okay, so मैं इस इक्वेशन को दोबारा लिखती हूँ. So x naught cross y is contained in w x naught cross y and this is contained in nx naught. So ज़हन में रखें nx naught is the union of finitely many elements of the open cover that we choose and depends on x naught. Okay, so now run x naught over, अब आप like x naught को छोड़ के अब x over, so run you can take x over the space X. So we get, so when you choose X, you have a slice, you have a neighborhood, and you have a tube. Okay, so when you change the X, you change the slice, you change the neighborhood, and you change the tube. Okay, so we get an open cover say WX, क्योंकि हर x के correspondingly आपको WX मिलेगा, and here your x depends on capital X, such that because x is the neighborhood, or sorry, WX is the neighborhood of X, such that X is contained in union of X belongs to X, WX. Now using the compactness of X, X, there exist WX1 and WX2 and so on, say WXN, such that your X is contained in union from 1 to N WXI. Okay. So, so using this equation, so you can say equation 1. So, so this implies X, because your X cross Y is actually equal to, you can say the union for X belongs to X, the slice X cross Y. Okay, so by using this and this, you get X cross Y is contained in union for X, union for I from 1 to N WXI cross Y. So you can see X is contained in this collection and X cross Y is the union of this, and using equation 2. So from 1, 2 and from 3. Okay. So you can write here from 1, 2 and 3. Okay. And this is contained in, from 1, this is contained in union from I from 1 to N NXI. Okay, X cross Y. So this implies X cross Y is contained in, so this happens from 3, from 1, sorry, from 1. 1 क्या आपकी, ये आपकी 1 है, ठीक है. So so as each NXI for 1 is less than equal to I is less than equal to N is the union of finitely many elements of your cover A. So this implies union from 1 to N NXI is finite. Is actually the finite union. Okay, so is the finite subcover of it, because each NXI is the finite union of A. So finite union, union again 2 times union of, because it will become something like that, I is equal to 1 to N, say I is equal to 1 to M, whatever, यहाँ पे जो भी होगा everything is finite. Okay, so so this implies your product space x cross y is compact because you have find the finite set. ठीक है? So this completes your proof. Thank you.